Welcome to the Math Record. Today we'll be covering the ICTM Regional 2016 Division A geometry. Okay, let's begin. Two of the faces of a solid black cube were painted orange and the rest were painted blue. Determine the number of faces that were painted blue, okay? So there's only orange and blue, and since there's six faces in a cube and two of them are orange, that means four is blue. So the answer is four. Okay, an easy question to start with. Number two, a triangle with vertices A, which is 0, 0, B, which is 6, 0, 6, 0, and C, which is 0, 8. Determine the length of BC. Okay, so when they give us questions like these, I usually like to draw a coordinate plane if they're giving coordinates. So that's 0, 0, that's A. 6, 0 is B. You just draw a general picture. And C, which is 0, 8. Okay, so they want the length of BC. Okay, so they want this length. So if you know a Pythagorean triple, which is 3, 4, 5 as our right triangle, right? The 3 goes with the 6 and the 4 goes with the 8. So 4 times 2 is 8. 3 times 2 is 6. So 5 times 2 is equal to this length, which is 10. So the length of BC is 10. And that's basically it. Number 3. One of the angles of isosceles trapezoid has a degree measure of 42. Determine the largest possible sum of the degree measure of two of the other angles of a trapezoid. Okay, since this is isosceles trapezoid, that basically tells us that this angle is A. Let's call that A, and let's call this A, because that means they're the same thing, because they're isosceles trapezoid, so these have to be the same. And this is B, and this is B, because it's also isosceles. So the top angles have to be the same, and the bottom angles have to be the same. And these two lines are parallel. So if you kind of extend this line out, that means this angle has to equal to this angle. So since this angle is B, that means this angle is also B. That tells us that B plus A has to be 180. Okay, so they say that a isosceles trapezoid has a degree. One of the angles have a 42. So the smaller one is right here, which is 42. So if this angle is 42, that means this angle is also 42. So that's 180. So A is equal to 180 minus 42, which is equal to 138. So the sum of the largest possible sum of the two other angles is A plus A, right? Because they're both obtuse, while this B is acute, right? So they're less than 90, and these are greater than 90. That means you just have to add both of them together. So it's 138 plus 138, or you could just have 138 times 2, which is 276. That's your answer for number 3. Basically, you just need to know the properties of a trapezoid. Okay, number 4. In the diagram, not showing the scale, A, B, D lie on the circle O, right? So, and CD is tangent at D. A, B, C are collinear, and AB is a diameter. And CD, okay, so let's kind of draw this picture out. Okay, yes, best drawing alive. And something like this. Okay, and they say CD, this is 12. And BC, this is 4. And since this is a diameter, that means this is the radius, and this is also a radius, and this is also a radius. Okay, and they say they want the area of COD, so they want the area of this triangle right here. Let's first find the radius. So if you know inscribed angles and lines, one of the properties is basically to find this radius. All you have to do is add the entire side length right here, which is r plus 4, which is 2r plus 4, multiplied by the outside part, which is 4, is equal to that line squared. So it's 12 squared. Okay, that means 2r plus 4. So 12 divided by 4 is 3. 3 times the other 12 is 36. So 2r is equal to 32. So r is equal to 16. So our radius is equal to 16. Let's kind of draw a different picture, right? So radius plus 4 is 20. So that length is 20. This is 12, right? And this radius right here is 16. Okay, so our area is just base times height. So 12 times 16, because this is a right angle. If it's tangent, it's a right angle. So CD is tangent to D, right? So this has to be a right angle. That's why this is a right angle. So 12 times 16 times half is equal to the area. So 8 divided by 2 is, 16 divided by 2 is 8. 8 times 12 is 96. So the answer for number 4 is 96. Okay, number 5. The equation of the line that passes through the point -3, -4 with a slope of 2 can be written as y equals kx plus w. Determine the sum of k plus w. Okay, so y is equal to 2x, and it goes to a point -3, -4. So that means 2 times, so it goes to -3, -4. So 2 times -3 is -6, so we need to get to -4, so we just need to add 2. So -6 plus 2 is -4. So this is the equation. So 2 plus 2 is 4. So 5 is equal to 4. Okay. 6. AC is a diameter of O. Point B lies on the circle such that BAC is 60. So let's kind of draw this. So this is a circle, O, and we have AC as our diameter, right? So this is our center, yes, O. And B is some random point, right? So this is B. And they said this is 60 degrees. And they say AB, this length is equal to 10. Okay. Determine the length of the radius O. So we want to find the radius, right? So these are both the radius. Okay, so let's connect lines B and C. So if you know inscribed angles on lines, basically, whatever whatever the angle is, whatever the arc that makes that inscribed angle, it's gonna be half of that. Okay, so this arc is 180, right? Because this is diameter. So half of that is 90. So this angle is 90 degrees. So it's just a right triangle. So if this is a right triangle, um, that tells us we have a triangle. So let's kind of redraw that out. And that's 60 degrees, and this length is 10. So that means this is 30 degrees. So if you know a 30, 60, 90 triangle, the general triangle looks like this. And we have a 60, 30. So if the hypotenuse is length x, then the opposite side of the 60 is x times square root 3 over 2, and the opposite side of the 30 is x over 2. Okay, so let's look at this. The opposite of the 30 is 10, so the opposite of the 30 is x over 2. So that means x over 2 is equal to 10. So that means x is 20, so the hypotenuse is 20. So this entire diameter is 20. Divide by 2 to get the radius. So the radius here is 10. So the answer for number 6 is just 10. And that's just basically if you know your properties. Okay. Number 7. A triangle has sides with lengths 5, 6, and 8. The area of this triangle can be expressed as k squared w over f in simplified and reduced radical form where k, w, and f are positive integers. Determine the value of k plus w plus f. Okay, so to get an area of a triangle with just the side lengths, you're gonna have to know something called I think it's called Hero's formula, or it's called Heron. I'm not exactly sure. I don't remember. It's one of those. But basically, what you're gonna do is you're gonna take the square root of s times s minus a, s minus b, and s minus c. Okay, so you're gonna multiply all those four together, and you get the area. A, B, and C are the three side lengths. It doesn't matter. You don't have to put it in any order. And S is equal to A plus B plus C divided by 2. So it's equal to the semi-parameter. Okay, so let's do this. So 5 plus 6 plus 8, that's 11, that's 19. So 19 divided by 2 is your semi-parameter. So square root times, so 19 over 2 minus 5, that is equal to 10 over 2. I mean 9 over 2. And then 19 over 2 minus 6 is equal to 7 over 2. And 19 over 2 minus 8 is 3 over 2. Okay, so we can move the 1/2. That 1/2 times 1/2 is 1/4. And there's two of them, so we could distribute that out. So that's 1/4 square root 19 times 9 times 7 times 3, right? So that means we could take out the 9 because it's a perfect square. So square root of 9 is 3. So 3/4 square root 19 times 7 times 3, right? So the other ones are not perfect squares, so you just multiply them. So 19 times 7 times 3 is equal to 393. So this is the same thing as 3 square root 399 over 4. Right, I'm sorry if I said 393. It's 399. Okay, so K is equal to 3, W is equal to 399, and F is equal to 4. So adding that together, we have 406 as the answer for number 7, I believe. Yes, number 7. Okay. Number 8. An angle has degree measure at 2/3 x minus 15. The supplement of this angle is 36 less than 3 times the complement of this angle. Find the degree measure of the original angle. So the original angle is 2/3 x minus 15. So the supplement of this angle, supplement is 180 minus that angle. So minus 2/3 x minus 15 is 36 less. Okay, so it's 36 less, so you have to add 36 because it's less than amount. So it's 36 less than 3 times the complement. So 3 times the complement. So complement is 90 minus that angle, so 90 minus 2/3 x minus 15, right? So this equation is true. So we have 180 minus 2/3 x, and then minus a negative 15 is plus 15, plus a 36, which is a plus 51. It's equal to 3 times 90, which is 270, minus 2x, right? Because 3 times this 2/3 to make negative 2x, because there's a negative here. And this one is a plus 45. Okay, so we have 270 minus 180, so that's a 90. And we have 45 minus 51. So this side is going to become a negative 6. So this makes it 84 on this side. Is equal to, move the 2x to the other side, so 2x minus 2/3, which is equal to 4/3 x. So x is equal to 84 times 3 divided by 4. That is equal to 63. So that's not it. We need to find that's not the angle. We need to find the 2x, uh, 2/3 x minus 15. That's our original angle. So plug in x. So 63 divided by 3, that's 21, times 2 is 42. So 42 minus 15 is equal to 27. So original angle for number 8 is 27. You can put degrees if you want as units, but it doesn't really matter. You just need the answer. In triangle ABC, AB is equal to 13 and AC is equal to 5. The medium from, okay, so let's kind of draw this out. So we have a triangle. So we have A, B. AB is, looks like a D. AB is equal to 13 and AC, this is C, is equal to 5. Okay, and the medium from A to BC. So if you draw a line here at this point where these two lengths are the same, right? So these two lengths are the same. Then it tells us that the medium is 6. Median is 6. Determine the numerical area for this entire triangle. Okay, so what we could do here is that we could use something called Stewart's theorem. Okay, so this theorem tells us that if I kind of draw a general picture, and we call this A, B, and this is M and N, and this, let's call this medium length D, then it tells us that A squared times N plus B squared times M is equal to, I'll just write on the bottom, just know that it's equal to that. It's equal to M plus N in parentheses times D squared plus M plus N in parentheses times an M times an N. So this equation is always going to work. So let's kind of use this theorem to find out what find out what this length is, right? So let's kind of label one of this is x and this is also x because they're the same, right? So 13 squared is 169. I'm just gonna write a little over so we get a little bit more room. 169 times x plus 5 squared, which is 25x, is equal to x plus x, which is 2x, times 6 squared, which is 36. So 36 times a 2x is 72x, plus a 2x times a x times a x. So that's got to be 2x cubed. So take away all the x's because they're basically have x's everywhere. So this cube becomes a 2. So we have 169 plus a 25, which is 194, is equal to 72 plus 2x squared. So subtract that out. So 122 is equal to 2x squared. So 61 is equal to x squared. So x is equal to square root 61. Okay, so we know what x is now. So let's kind of clear all this out because we don't need it. So we know x is equal to square root 61. So square root 61, square root 61. And now we could use something from our past question, which is from one of our past questions, which is called Hero's formula or Heron's formula, which we use for number 7, right? So we could have based on the 3 side lengths. So our 3 side lengths was 13, 5, and both of these square root 3s because I split them in half. I mean square root 61s. So it's 2 square root 61 as our last side lengths. It might seem like it's gonna come out ugly, but it's gonna actually be a really nice answer. So let's delete this and move this over. Okay, so those are our 3 side lengths. Okay, so Hero's formula, 13 plus 5 plus 2 square root 61, that's 18 plus 2 square root 61, divided by 2 is equal to our summary parameter, which is 9 plus square root 61. Okay, so square root 9 plus 2, 9 plus square root 61. Okay, we're first going to subtract the 2 square root 61. So 9 plus square root 61 minus 2 square root 61 is 9 minus square root 61. Make this a little longer. Times 9 plus square root 61 minus 13 is equal to negative 4 plus square root 61 times 9 plus square root 61 minus 5, which is 4 plus square root 61. Okay, so let's just do these first, these as a pair first, because it's going to simplify really nicely. So 9 times 9 is 81. 9 times square root 61 is negative 9 square root 61. And 9 plus square root 61. And then minus square root 61 times square root 61 is 61. Right? So this terms cancel out with this one. So all we have left is that 81 minus 61. Oops. Oh, sorry. Zoom out. Sorry about that. Okay. So we have a 81 minus a 61. And the same thing happens on this side. So let me add that square root in. It's equal to negative 4 times 4, which is negative 16. Right? So that's negative 461. That's 4 square root 61. So that cancel each other out. And then square root 61 times square root 61 is plus 61. Okay. So this simplifies to 20. And this one simplifies to 45. So 20 times 45 is equal to 900 because 45 times 2 is 90. So 90 times that 10 is 900. So square root 900 is 30. So the area for number 9 is equal, or the answer for number 9 is equal to 30. Okay, let's kind of move this over. So number 10, a quadrilateral is formed by equilateral triangles sharing a side with lengths of the right triangle. So determine the area of the quadrilateral. Since all this information gives us is basically repeating what this diagram is, so we don't have to waste time trying to do it. So we have a diagram like this, where this is a right triangle, and that's the equilateral triangle. So 2.7, 2.7, and this is 4.9. So if this is equilateral, that means this is 2.7. So the area of a equilateral triangle is always x squared square root 3 over 4 times square root 3 over 4, where x is the side length. So the area of this equilateral triangle is just 2.7 to square root 3 divided by 4, because x is just the side length. Okay, so that's the area of our equilateral triangle. Now we need to find the area for our right triangle. Okay, so we need to find just the height on this part. So you use the Pythagorean theorem. So 4.9 squared minus 2.7 squared square root is equal to the side length. And to get the area, you have to have that side length times the other side length, which is 2.7, divided by 2. So I'm just going to put this in parentheses, times 2.7 divided by 2. It's equal to this area. Now we add them together and see what the answer is. So using our calculator, we have 2.7 times 2.7, this is 2.7 squared, times square root 3, and then divided by 4, and then you add a 4.9 squared minus a 2.7 squared, okay, times a 2.7 divided by 2. Okay, so you get an answer of 8.677 with 4 significant figures. So 4 significant figures means you have like basically 4 digits. So right, so that's 6.77 rounded. So that's your answer for number 10. Okay, so let's move on to number 11. In the diagram, PW and PZ are secant to the circle, where uh, ZY and WX are equal. So these have the same length. That means arc WX and ZY is also it's the same. And the degree measure of WZ uh, Y is equal to 200. So determine the measure of P. Okay, so we have something like this. And this is W, this is X, and this is P, and this is Z, Y. And they told us that this entire angle right here, this entire angle, is equal to 120. So let's call this A, and let's call this B, right? So ZY is B. And they told us that ZY and WX is equal to each other. So this angle is also B, right? And let's call this angle C, okay? So we know this entire circle is 360 because that's just a circle. So if W zy is equal to 200, so A plus B is 200, that means B plus C has to equal 160 because that's the other that we didn't account for because it had to make up 360, right? 200 plus 160 is 360. And to find the angle of P, you just need to find 1/2 times parentheses A minus C. That's just an inscribed angle and lines question property. So to get that, we just need to have from here. So half the first equation subtract by the second one. So 200 minus 160 is 40. So then the A plus B minus the B minus the C is equal to A minus C. So we got this portion down. Oh, sorry. Why does that keep happening? Okay. So we got this portion right here. So 1/2 times the 40 is equal to 20. So our answer for number 11 is 20. Okay, number 12. In diagram ACB, AD is equal to... Okay, so let's kind of like draw this picture before I continue. We know ACB is 20. I mean, a right angle. ACB is a right angle. I don't know why I said 20. Cut. And they said that AD is 5, so this is 5. And they say DC is 10, so this length is 10. And BC is equal to 20. Okay. And EB is equal to 17, so this length is 17. So we need to find this length. So this is a 15 together, so 15 and 20. So this kind of reminds us of a 3, 4, 5, right? This side length is 15 in total, and this is 20, right? So 4 times 5 is 20, so 3 times 5 is 15. So this side length is just 5 times 5, which is 25. So if this is 17, that means 25 minus 17, this is 8. Okay, so that one is side length 8. So if you know your Pythagorean triples, basically. Delete. Okay, so to find the area of a triangle, we don't even need like the last one because this is part of the right triangle. So let's call this angle A. So this angle right here is A. Okay. So the area of of a triangle is always going to be two side lengths, A times B, multiply them together, multiplied by the sine of the angle between them. Actually, let's call this actually, no, let's call the side lengths x and y because I don't want to confuse you. So x times y times the side times the angle between them, so sine of A, and then divide by 2. That's the area. Okay. So what is the sine of this angle? So the sine of this angle is just going to be opposite over hypotenuse. Opposite of this angle is a 20. Over the hypotenuse, 8 plus 17 is 25. So sine of A is equal to 20 over 25, which is simplified to 4 over 5. Okay, so we know that's true. So that's the angle between 5 and 8. So to find the area, it's just 5 times 8 times 4, or 5, divided by 2. So 5 and 5 cancel out here. 8 times a 4 is equal to a 32. Divided by that 2 is equal to 16. So our answer for number 12 is just 16. Okay. Number 13, the numerical answer of a rectangle is 24, and the numerical perimeter of the rectangle is 20. So determine the exact length of the diagonal. So let's call this x, and we call this y, right? So they've given us that x times y is equal to 24, and that the numerical perimeter, so 2 times parentheses x plus y, right? Because 2x plus 2y is equal to 20. So that means x plus y is equal to 10, right? Because 20 divided by 2 is 10. So x plus y is equal to 10. So the diagonal is equal to x squared plus y squared and then square root, right? Because it's basically just going to be a triangle. So x squared plus y squared, square root. Okay. So to find the length of this, we don't even need to find what x and y is. All you have to do is rearrange these. So what is, instead of thinking of x squared plus y squared, think of x plus y squared in parentheses. That expands out to x squared plus 2xy plus y squared, right? So we have our x squared and we have our y squared. So we need to find our 2xy, but we already know what that is, right? We know it's x times y is 24. So if we want only the x squared plus y squared, we could just have x plus y squared, and then we move this to this side, so it's minus 2xy is equal to x squared plus y squared, right? So this is the same thing as saying we need to find the square root of x plus y squared minus 2xy, right? So we just need to find this. Oops. Ah, sorry about that. I was trying to delete all this. Okay, and let's move this up. So we need to find this. So we could just plug everything in. So x plus y is 10. So that's 10 squared minus 2 times xy. So xy is 24, so minus 48. So this is 100 minus 48, which is equal to 52. So square root 52 is equal to 2 square root 13, right? Because 4 times 13 is equal to our 52. So our answer for number 13 is equal to 2 square root 13. Okay, 14. In the right triangle shown below, x plus y plus z is equal to 2 times, in parentheses, square k plus square w plus square p in simplified and reduced radical form with kwp positive integers. Determine the sum of k plus w plus p. Okay, so let's kind of draw a picture. And if this is a right triangle and we draw a height, and that is also a right triangle. So there's a property over here for this right triangle. If you use like similar angles, similar triangles, it tells us that if this is h and these lengths is a and b, the property is that h squared is equal to a times b. So that is always going to be true if it's a right triangle inside right triangle, right? So there's a right triangle inside a right triangle, right? So using that idea, we see in 14 that there's a right triangle and right triangle, right? So that means x squared has to be equal to 2 times the 10, which I just told you. So 10 times 2 is 20. So x is equal to 2 squared 5, right? Because 4 times 5 is 20. So if x is equal to 2 squared 5, we could use that in our picture to find z. We just use the Pythagorean theorem. So 2 squared 5 squared plus 2 squared is equal, square root is equal to z. So that's 20. 20 plus 4, that's 24. So square root 24 is equal to 2 square root 6. And if you want to find y, that's just square root 2 squared 5 squared plus 10 squared. So that's 20 plus 100, 120. So that is equal to 2 square root 30. So we had to add everything under the radicals. So 5 plus 6 plus 30, that's 41. So our answer for number 14 is 41. Okay, trapezoid ABCD is inscribed in a circle. Angle A is 40 and AB is 120. Determine all possible degree measures of arc CD. Okay, so we have a circle and we have trapezoid inside. So not the best picture. So A, B, and C, D. And they say AB is equal to 120. So this arc length is 120, and A is equal to 40. So it, the property uh, of a trapezoid inside a circle is that, right, if you kind of move this out, then as we shown before, this angle has to equal to this angle. So 180 minus the 40 is 140. So if this is 140, that means this has to be 140. Okay. So also another property of a trapezoid inside a circle, inscribed inside a circle, is that the opposite sides have to add up to 180. So if this is 40, then this is also 140. It has to be true, which is just a property of a trapezoid inside of a uh, I mean, it's just not just a trapezoid, but it's also for quadrilaterals, I believe. So any quadrilateral inside a circle, if it's inscribed, then opposite angles have to add up to 140. I mean 180. So 40 plus 140 is 180. And if this is 140, then this is also 40. Okay, so the special case of a trapezoid inside a circle is that it has to be an isosceles trapezoid, right? Because they're both the same on top and both the same on the bottom. Okay, so find the angle of CD. So they want to find this length right here. So all we need to do is find this angle, right? So if this angle is, oops, oh, okay. So we need to find this angle. Half of this angle is equal to CD, and we know that this angle is also going to be part here. So let's kind of find out what that is. So first we are given that this 220, right? So if we kind of move an angle right here, that means this angle has to be half because it's an inscribed angle. If you know inscribed angles and lines. So 220 divided by 2 is 110. So if this is 110 and this is 140, right? So this is 110. That means this side is 30. So if this is 30, that means this is not inscribed. That means this arc length right here is 60. So erasing on that, that means this is 60. Okay, so since we know that these are isosceles, if this is 60, that means this has also to be 60, right? So 120 plus 60 plus 60, 120, 220 plus 60 plus 60 is 340, right? And a whole circle is 360, so 360 minus that 140 is equal to 20. So our arc length for CD is equal to 20, and that's for 15. Number 16, decagon A and B. So we have two decagons. We have decagon A, we have decagon B. And a side of decagon B equals the perimeter of decagon A. So a decagon has 10 side lengths, has 10 lengths, and they said it's regular, so each of the lengths are the same. So a side of decagon B is equal to the length of a decagon A. So that tells us that decagon B, it has a side length of 10x and this is x, right? Because if A, the perimeter of A is 10A, and the length of a side of B is equal to the perimeter. So the side of A, which is x, is equal to the perimeter of B. So equals to, the side of B, which is 10x, is equal to perimeter A, which is x. Kind of confusing statement, kind of weird. So that means the area of B is k times the area of B is greater than A, right? K times A. Ugh, I can't speak today. So that basically is 100 because 10 times 10 is 100 because 10 squared is 100. So that's your answer. So the reason it's 100 is because if you have a regular shape, right? Let's say we have something like this. It's a triangle instead of a um a decagon. It has to be regular though. The shapes has to be regular. So it doesn't have to be regular. They have to be similar. But if they're both regular, then they both have to be similar. So let's say this side length is A, this is B, and this is C, and this is 2A, and this is 2B, and this is 2C. That means if this one has area A, then this area is 4A. This is 2 times 2 times 4A. Same case, if you have a similar triangle, and this is 3A, this is 3C, and this is 3B, right? Then this area has got to be 9A, 9 times A times this area, right? Because it's 3 squared times 9. That's just the idea of similar like shapes. So if B is 10 times the side length of A, that means this area has to be 10 squared times bigger. So 10 times 10 is 100. So your answer for number 16 is 100. Okay, number 17. The array of 12 points is set up in 3 evenly spaced rows and 4 evenly spaced columns. Okay, so one point is chosen at random from each row. Determine the probability that the 3 points would be collinear. Okay, so let's kind of draw it out. So we have 4 points and each row. So let's kind of keep track. So let's use red instead, actually. So if we choose the first point, that means the only ones that are collinear is right here and here, right? So we have two lines. And if we choose the second point, the only line that's collinear is here and here. So that's another two lines. And we choose this point, the only line collinear is here and here. So that's another two lines. And the only one that, if you choose this one, is going to be here and here, which is another two lines. Okay, so just kind of erase. So that means there are 2 plus 2 plus 2 plus 2, which is equal to 8 possible combinations, right? So it doesn't matter. If you choose this point, you could just, then the only one that you can make is here, right? But that's already accounted for because when we chose this one, we chose this line. So you're just going to repeat. So those are the only possible. So we have 8. So how many possibilities are there? Well, how many can you choose in the first row? That's 4. Times how many possibilities can you choose from the second? 4. And how many possibilities can you choose in the third row? 4, right? So this is the amount of possibilities on the bottom. So 4 divided by 4, there's a 2 on top. So divide by 2 here, that's 2 on bottom. So 4 times 2 is 8. So that means our probability is 1/8. And that's basically it. Okay. Number 18. A triangle has side lengths 4, 9, and 12. Determine the type of triangle that has these lengths, these side lengths. Okay. So first we gotta check if it's actually a triangle. So 4 plus 9 is 13. So 13 is greater than 12. So that is gonna be a triangle because the sum of the two smaller sides is bigger than the large side, the last side, which is the larger one. So now we could check. So first we're gonna have to square both of them. So 4 squared plus the 9 squared, that's 16 plus 81, which is 97. Okay, so 12 squared is equal to 144, and 12 squared is bigger than 97. So if you kind of think about this logically, right, let's kind of draw this out as a right triangle. So imagine this was a right triangle, and this was 4, 9, 12. It's not, but let's just imagine it. Okay, 4 squared plus a 9 squared is equal to 97, which is only part of it, so it's only right here, and this is the entire thing. So what this basically tells us that if this is square root 97, because that's the side length, but 12 is like all the way up here, right? That means the only way for this to get for it to combine with that 12 is that if this length 9, right, instead of being like this, has to be angled like this, and then has to put the 12, right? So the triangle will look something like that, where this is the 12, this is the 4, and this is the 9. So since this has to be higher than 9 degrees, that means it's obtuse. So thinking logically, okay? But also the general idea is that if we have three side lengths, A, B, and C, and A and B are the smallest, right? A and B are the smallest and C is the biggest, then if A squared plus B squared is smaller than C squared, then this is going to be obtuse. If A squared plus B squared is greater than C squared, then it's got to be a acute. And if it's equal to each other, that's just the Pythagorean theorem. That's a right. Okay. So those are the general formulas, but general ideas, but you kind of have to, but I kind of don't memorize them. Just think logically about it. Quadrilateral ABCD has coordinates 0, 0, 5, 2, K, W, and 2, 5. Determine the coordinates of C so that the quadrilateral ABCD is a parallelogram. So usually I like to draw a picture. So we have A, we have B, which is at 5, 2, so 5, 2 is from right here, and then D, which is at 2, 5. So this is A, B. Since it's a parallelogram, it has to be somewhere like right here because it's kind of matching. So this is C and this is D. Okay, right? So they say it's a parallelogram. So what to get from A to B, uh, from the X to the Y is the same thing. So this kind of really bad picture, but somewhere like up here, right? It's the same thing as this and this has to be the same length, and this has to be the same length. Okay, so something like this and something like this, right? Like this. So to get from A to B, right, we could just look at our coordinates that are given in question 19. We had to go from A to B. We had to go 5 to the right and 2 up, right? Because 0, 0 to 5, 2. So it's got to be 5 right plus 2 up. Okay, so that means to get from D to C, you have to add 5 right to 2 up. So D is at equal 2 comma 5. So 5 up, that's 7. And 5 to the right, so 2 plus 5 is 7. And 2 up, so 5 times 2 is 5 plus 2 is 7. So the coordinate of C is equal to 7, 7. 7 comma 7. Number 20, in triangle ABC, the altitude from A to BC intersects CD between B and C, and the foot of the altitude has coordinates negative 2, 3. An equation of the perpendicular bisector of BC is 2x plus y is equal to 4, and the equation of the medium from A is 3x plus 4y is equal to 16. Determine the coordinates of A. So this is a mouthful and it's kind of weird. So let's kind of draw a picture. So we have a coordinate plane. And they said that the foot of the altitude is negative 2, 3. So somewhere right here. And they say the perpendicular bisector is at 2x plus y is equal to 4. So something like right over here, right? So something like that. Where's a perpendicular bisector? And this line is 2x plus y is equal to 4. So if it's a perpendicular bisector, that means it's perpendicular to the line of where the triangle is. So we have a line, and that's a right triangle. I'm just bad at drawing. Okay. So actually, let's kind of draw a little nicer. Okay. Uh, I am bad at drawing. So something like this, right? So since it's a perpendicular bisector, that means this side length has to equal to this side length. So let's kind of make this a little shorter, so I don't have to go as far. Yeah. Okay, so this is fine. So this side length is equal to this side length. Okay. So, and they also said that the median from A is 3x plus 4y is equal to 16. Okay, so we have a median that goes in the middle, that goes into this line, and it has like some equation that's like this. So that tells us that the triangle has to be somewhere up here, the last point. So we have to have a point like, so the triangle is like somewhere right here. And if you make it altitude, that's where our 2/3 is at. So this is negative. I mean, this is where our negative 2/3 is at. And our line from that point to the right here, because a perpendicular bisector splits the base in half, right? That's why I said this is equal to each other. A median also does the same thing, median, right? So that line intersect at this point. So all we need to know is that if this is a perpendicular bisector, that means if you try to make a perpendicular bisector over to this is going to be the same thing as the altitude. We're just going to connect at this point. And that's where we want to find coordinate A, right? So this is 2x. So rearrange this. That's y is equal to negative 2x plus 4. So that means this equation must have a slope of negative 2x. And it has to go to the points at negative 2, 3. So negative 2 times 2 is 4. So yes has minus 1 to get to 3. So that's the equation of this line. And we already know the equation of A. A is equal to 3x plus 4y is equal to 16. So we just need to find x and y because that's where they're going to intersect. So 3x, we could just substitute this y into this y. So 4 times negative 2 is negative 8, negative 8x. And then 4 times negative 1, negative 4 is equal to 16. So that means negative 5x is equal to 20. So x is equal to negative 4. So if negative 4, you guys just plug into one of the equations. I'm going to use this one on the bottom. So negative 4 times 2 is 8. 8 minus 1 is 7. So coordinate A is equal to negative 4, 7. And that's basically it. They gave all this information so such that you could use the perpendicular bisector to find the equation of the altitude and then find the altitude and the median to find your actual answer, which is negative 4, 7. So overall, basically you just need to know formulas. Some of them are kind of like tricky, which is like 20 and like 12. But other than that, a lot of formulas you just need to memorize and just to. So one of the more common ones I've seen in this one is inscribed angles and lines. So you might need to know that and know your Pythagorean triples and equilateral triangles. And basically that's it. Just know your formulas. Well, thanks for watching, and I'll see you at the next math record.